So you end up with 1 is equal to a times what? A times what? Negative 3, right? So what's a going to be? Negative 1/3. So you go back up here, and what's a going to be? Negative what? Negative 1/3, and this is going to be 1/3. Now are both of these integrable quite easily? Yes. You're home free at this point. Saving grace, really nice thing about the BC exam. The only partial fractions you'll see, if any, you'll almost certainly see 1 or 2, single power linear terms. What do I mean by that? You see how the denominator, these are both single power monomials, not monomials, linear functions. Does it make it really straightforward, generally speaking, to do this algebra? Yes. You can make these really nasty. I could give you some nasty polynomial that you had to factor, and it might have some like 2x squared plus 5 to the third. It makes the decomposition algebra annoying. They don't want you to have to do that much algebra, so instead, the highest thing you'll see is a single power linear term. Is that happy? Yes, that's nice. What did someone try? Factor it. So you ended up with x plus 2 over x times what? X plus 1. I like that. So what did you do next? Tried to do partial fraction. Nice. So you're trying to solve x plus 2 over x times x plus 1 is equal to a over x plus b over what? What's the only thing that's different about this one? So only one small thing changed. What's the small thing? Yeah, the x plus 2 is sitting on that numerator, right? So when you do that multiplication, you end up with x plus 2 is equal to a times x plus 1 plus b times what? Does much change at this point? Not really, right? What's still a nice number here, Jesse? X equals what? What? Negative 1, right? So when you plug in negative 1, you end up with 1 is equal to b times what? Is that correct? Is b negative 1? Is that correct? So what's the other magic number? 0. Nice. So you end up with 2 is equal to a times 1. So a is equal to 2. So now can you solve this sucker? Yes, absolutely. So you might have to do a baby amount of, no, that's not a good highlighter right there. That's like really not helpful. Terribly not helpful. Okay, but you have your two numbers which you can plug in, and then you are happy. Yeah, dx is equal to what? Cosine theta d theta. So when we plug this in, we end up with 1 over the square root of 1 minus what? Sine squared theta, but instead of dx, what do we write? Cosine theta d theta, right? Well, what's 1 minus sine squared? So we end up with the square root of cosine squared theta times cosine theta d theta. Oh, what's the square root of cosine squared? That's kind of nice. So what do we end up with? We end up with the integral of what? D theta, right? So that's going to equal theta plus what? C. But what does theta equal? Oh, and I just totally missed writing that in the right place. What does theta equal? Sine inverse of what? X. So what do we end up with? Sine inverse of x plus what? Clever. Ooh, there it is. Exciting. I know. You're just totally thrilled with this. You're totally thrilled because you just spend your nights memorizing trig identities, just waiting for the day when you can just like go, magic trick, everything just folds away and I get to scare you away. Okay, wonderful. Nice. What about this one? What does this look like? It's the square root of what? 4 times what? 3 over 2 sine theta squared dx. I haven't done the other part yet, but this is so nice because when you square this, what happens? You end up with 4 integral of the square root of 9 minus 9 sine squared theta, like that. What can you pull out? A 3. So you end up with 12, the integral of the square root of 1 minus sine squared theta dx. What's that going to be equal to? 12 times the integral of what? So cosine theta dx. What's the only problem at this point? Oh, it's just cosine. Sorry. Yes, yes. Even nicer. Sorry. What's the only problem at this point besides my mistake? The dx. You can't have no mixed metaphors in this class. We're not in the multi-land yet. So what do we have to do up here? Yeah, dx is going to be what? 3 over 2 d theta, like this. So dx, so you take this, you throw it down here, and what do you end up with? 12 times the integral of what? cosine theta times 3 over 2 cosine theta what? D theta. So you end up with what? 8? Is that right? 8? No. 3 over 2. I'm sorry, I can't do math. 18. 18. Cosine squared d theta, like this. We're still not done. Why aren't we done now?
We need the bounds of...
There's two things that are not done. One, what am I very specifically not written in here? The limits of integration, right? The limits of integration. And also, if we were going to do this by hand, we still need to integrate this, right? Is this a trivial integration? No, it's not. We just learned how to do that, right? What method did we use to integrate cosine squared? Parts. We used parts. So we're going to pause here and realize I haven't put the limits of integration on it, right? And we're not done integrating. But have we done the heavy lifting so far? We have. It's like when you're in quadratic line, we've got it into a nice form and we can use the method we know. We have it in the nice form. Yes?
Can I just see what the previous...
With? Isn't that worse? Oh, come on. What's your one trig identity that you might remember out of this? Nope. Say